Hello. Please settle in, take a deep breath. Let's leave the day's worries and anxieties outside the door. Right now, there is only you, my voice, and the vast, silent void of space. Picture the perfect night sky, the kind you can only see far away from any city lights. Billions of tiny, distant pinpricks of light. Each one is a colossal sun, a world brimming with energy and power. They have been shining for millions and billions of years, governed by the great, unwavering laws of physics. Now imagine that on one quiet night, as you gaze upon this eternal canvas, the unthinkable happens. One star, then 1,000, then 1,000,000, all of them, as if commanded by an invisible conductor, simultaneously dim for a fraction of a second, and then, just as synchronously, they blaze back into existence. The entire sky is pulsing like one massive, living heart. It sounds like the opening scene of a science fiction novel, doesn't it? But what if I told you that this exact phenomenon is currently baffling the planet's top astronomers? In today's lecture, we are going to dive into the most profound and unsettling mystery facing modern science. We will try to understand why the stars have begun to flash in unison and what this could potentially mean for humanity. Prepare yourself for a calm yet long journey to the very edge of our knowledge. Before we head to the epicenter of this mystery, let's first paint a picture of how the universe should behave in its normal, predictable state. Space is not a static backdrop. Stars are born, they live, and they die. And yes, some of them genuinely do change their brightness. We call these variable stars. Take Cepheids, for example. They pulsate, smoothly increasing and decreasing their brilliance with incredibly precise periodicity. We use them as cosmic lighthouses to measure the distance to other galaxies. We have cataclysmic variables, binary star systems, where one stellar body pulls matter from the other, causing irregular, dramatic flares. We also have pulsars, the remnants of exploded stars, which are dense neutron stars spinning at immense speed, emitting beams of radiation like a cosmic searchlight. To an Earth observer, these appear as stars blinking with perfect clockwork precision. But the key word here is individuality. Every variable star, every pulsar, is a soloist in a gigantic cosmic orchestra. Each one has its own unique rhythm, its own cycle, its own history. They are not connected. A star in the Orion constellation has no way of knowing about a star in the Andromeda galaxy, let alone agreeing to perform a synchronized concert with it. The probability of even two independent variable stars accidentally synchronizing their cycles is vanishingly small. The chance of thousands or millions of stars separated by light years doing this is zero. It is simply impossible according to everything we know about physics. This is the fundamental rule that has been broken. This is precisely why the quiet focus in laboratories and observatories has been replaced, first by disbelief, and then by barely concealed alarm. It all began in the profound silence of the Chilean Atacama Desert, one of the driest and darkest places on Earth. Perched high atop Cerro Pachon is the Vera C. Rubin Observatory. This isn't merely a telescope, it's a technological marvel, a true behemoth built for a singular purpose, to compile the most comprehensive dynamic map of the universe, a project dubbed the Legacy Survey of Space and Time. At its heart is a gigantic 3.2 gigapixel camera capable of capturing a swath of sky 40 times the size of the full moon in a single exposure. Every night, the system gathers terabytes of data, logging the slightest variation in the brightness of billions of celestial objects. This deluge of information is processed not by human eyes, but by sophisticated self-learning algorithms. Their mission is to flag anomalies, asteroids, comets, or sudden supernova flares. Then one night, the system returned a signal that defied all known categories. The algorithm, specialized in searching for transient phenomena, detected a coordinated drop in brightness across 74% of all observed stars in a specific sky sector. Initially, it was dismissed as a systemic glitch, maybe a speck of dust on the lens, a brief electrical fluctuation in the camera, or perhaps even a satellite reflecting sunlight into the aperture. This was the most rational explanation. The team of engineers and astrophysicists spent days exhaustively checking every system on the telescope. They pored over the telemetry, calibration data, and error logs, but the equipment proved to be functioning flawlessly. They then cross-referenced the data with previous night's observations. To their mounting horror, they realized this was not an isolated event. The strange, synchronous pulse was repeating, and its period appeared to be subtly shifting over time. It was faint, right at the limit of their instrument's sensitivity, but it was unmistakably there. The profound realization that this was genuine, not a glitch, set in slowly and reluctantly. It felt like standing alone in a silent house, hearing a faint, inexplicable whisper, and desperately trying to convince yourself it's just the wind. But then the whisper repeats and you realize you are not alone. The astronomers understood they had encountered something entirely beyond their comprehension, something that demanded a complete re-evaluation of the fundamental principles of their science. Once the initial team at the Vera C. Rubin Observatory had definitively ruled out equipment failure, they moved on to the next critical phase, checking for external interference. The most obvious candidate was Earth's own atmosphere. It's a dynamic living system whose turbulence makes stars twinkle. Perhaps some previously unknown, large-scale atmospheric effect was creating the illusion of synchronously changing star brightness. To test this hypothesis, they contacted other observatories scattered across the globe. Urgent requests were sent to the European Southern Observatory, also located in Chile, and to facilities in Hawaii and the Canary Islands. Crucially, they also requested data from space telescopes like the Hubble and James Webb, whose observations are completely immune to atmospheric influence. The replies began flooding in over the next 24 hours, and each new piece of information only deepened the mystery. Every terrestrial observatory whose field of view overlapped with the anomalous patch of sky confirmed the strange pulsation. But the ultimate blow to their hypothesis came from the space telescopes. They had recorded it too. This was the decisive proof against the atmospheric interference hypothesis. The phenomenon wasn't occurring in the air above our planet, it was happening out there, in deep space. The next logical step was to check for possible interference originating within the solar system. Could a cloud of dust or gas be passing between us and the distant stars, partially obscuring their light and creating this effect? Theoretically, yes. However, such a cloud would need to be impossibly vast to cover such a significant area of the sky. Furthermore, its movement would have caused parallax, meaning the effect would appear different when viewed from various points along Earth's orbit. But the telescope data, collected months apart when Earth was at different positions on its orbital path, showed zero parallax. The effect was entirely static. It was not linked to anything local. Slowly, painstakingly, ruling out one logical explanation after another, the scientists narrowed the possibilities down to a single, terrifying conclusion. Whatever was causing this phenomenon, its source lay far beyond our solar system, deep within interstellar space. It was now undeniable the phenomenon was real, and its source lay deep in space. The next major challenge for astrophysicists was simply describing it. What exactly was happening to these stars? This wasn't a simple flicker like a dying ember. This was a slow, almost majestic dimming, followed by a steady return to normal. Imagine a standard dimmer switch turned down incredibly smoothly and then brought just as slowly back up. The drop in brightness was only a few percent, negligible to the naked eye but utterly obvious to sensitive instruments. The entire cycle lasted about 17 hours. The stars would slowly fade for 8.5 hours, reach their minimum, and then spend an equal amount of time returning to their normal luminosity. But the most staggering detail was the striking synchronicity. The time difference between the onset of dimming for stars, separated by thousands of light years, was only a matter of seconds. This implied that whatever signal was causing this dimming, if we could even call it that, had to be traveling at a speed many times greater than the speed of light, or it had been initiated simultaneously across vast reaches of space. Both scenarios grossly violated Einstein's special theory of relativity, a fundamental law of our universe. Further analysis of the stars' spectra during the dimming brought forth even more puzzles. Spectral analysis, breaking down a star's light into its component colors to determine chemical composition, temperature, and other parameters, is standard procedure. Scientists had expected to see some change in the spectrum. For example, if the light were being blocked by a dust cloud, the star's color balance would shift. Instead, the spectrum remained absolutely unchanged. The star simply became dimmer, exactly as if someone were turning an invisible luminosity dial. It wasn't cooling down and its chemical composition wasn't shifting, it was simply emitting less light. This was physically impossible. For a star to change its luminosity, internal processes must occur, and those would inevitably be reflected in its spectrum. Yet, nothing of the sort was observed. It felt like a magic trick, an illusion playing out on a galactic scale. Initially, the anomaly was detected in one sector of the sky, but as more observatories across the globe joined the monitoring effort, it soon became evident this was not a localized phenomenon. A synchronous pulsation was observed everywhere. No matter where telescopes turned their lenses, no matter which constellation they examined, the effect was identical. It reached stars in our own Milky Way, both near and far. It reached stars in neighboring galaxies, the Andromeda Galaxy, the Triangulum Galaxy, the Magellanic Clouds. It seemed the entire observable universe was subject to this phenomenon. This realization was truly staggering. A mystery confined to a single star system, or even a galaxy, is one thing. A phenomenon encompassing all of creation is quite another. This called into question the very nature of space and time. However, a closer look revealed a strange and defining feature. Not all stars were participating in this performance. Only stars of a specific type were pulsing. These were primarily main sequence stars, similar to our Sun, along with yellow and orange dwarfs. The very young hot blue giants and the old cold red dwarfs appeared completely immune to the effect. They continued to shine with their steady light, as if nothing unusual was happening. This selectivity was both a vital clue and yet another puzzle. On one hand, it suggested that the cause of the phenomenon might lie in specific physical processes inherent to this particular stellar class. Perhaps it was an unknown form of stellar resonance that only stars within a certain mass and temperature range could enter. On the other hand, it made hypotheses about an external influence, say, the passage of some unknown dark matter, far less likely. Such a force ought to have affected all stars equally. This selectivity hinted at something far more subtle and intricate. It was as if some force wasn't merely causing the stars to blink, but was doing so deliberately, choosing specific instruments for its universal orchestra. This was a speculation too fantastic to voice aloud, yet it hung heavy in the air in every telescope control center. Confronted by the impossible, the scientific community frantically sifted through every conceivable and inconceivable physical theory that might offer even a remote explanation for what was happening. The first idea to surface was gravitational lensing. According to Einstein's general theory of relativity, massive objects, like black holes or clumps of dark matter, can warp space-time, forcing light from distant objects to bend around them. This process can distort the image and alter the apparent brightness of remote stars. One might hypothesize that some massive, invisible object was passing between us and the observed stars, but that hypothesis collapsed almost immediately. Firstly, to cause a simultaneous change in brightness across stars spanning the entire sky, the lensing object wouldn't just need to be enormous, it would have to be all-encompassing, essentially surrounding our entire galaxy. No theoretical models predict the existence of such a structure. Secondly, gravitational lensing typically magnifies light rather than dimming it, and causes characteristic distortions in the shapes of distant galaxies, none of which were observed. And thirdly, it failed to explain the selectivity of the effect, why only stars of a very specific type were being impacted. Another exotic idea involved dark matter. This mysterious substance makes up about 27% of the universe's mass, but interacts with light and ordinary matter only through gravity. What if there were some unknown forms of dark matter that could interact with stars, perhaps passing through them and temporarily suppressing the nuclear fusion reactions in their cores? While this sounded like pure science fiction, theoretical physics often explores far stranger concepts. Yet, insurmountable obstacles arose here as well. To cause a synchronous effect across the entire universe, a wave of this matter would have to blanket everything simultaneously, which, once again, violates the principle that nothing can exceed the speed of light. Furthermore, it was unclear why this hypothetical matter would interact only with solar-type stars. Every new theory born in the minds of physicists slammed into a wall of contradictions and inconsistencies. It seemed as if the universe itself was mocking humanity's attempts to explain it using its limited, rudimentary laws. Once the initial, most obvious physical hypotheses were ruled out, scientists started looking into deeper, more fundamental ideas. What if the problem wasn't with the stars themselves or the space between them, but with the very laws of physics? Perhaps we were observing the manifestation of a new, previously unknown force of nature, or a change in one of the fundamental constants, the gravitational constant, for instance. If this constant were periodically changing across the entire universe, it could dramatically affect the processes occurring inside stars. A shift in gravity would cause the stellar core to contract or expand, which would, in turn, alter the rate of thermonuclear reactions and, consequently, the star's luminosity. This hypothesis was particularly elegant because it explained the phenomenon synchronicity. If the constant itself is changing, that change happens everywhere at once. It could also account for the observed selectivity, as stars of different masses and compositions would react differently to shifts in gravity. But this idea carried one fatal flaw. The gravitational constant is one of the foundational pillars holding the entire universe together. If it started to fluctuate, the consequences would be catastrophic. Planetary orbits would become unstable, and galaxies would either fly apart or, conversely, collapse in on themselves. We would observe chaos, not an ordered blinking pattern. Yet nothing of the sort was observed. The solar system remained stable, and the movement of galaxies was undisturbed. This meant that if any constant was changing, it wasn't gravity. So perhaps it was the fine structure constant which governs the strength of the electromagnetic interaction, or maybe one of the 24 other constants that underpin the standard model of particle physics. Theorists began constructing models where one of these constants underwent tiny oscillations. It was akin to trying to find the right key for a lock with an infinite number of combinations. Every such model required the introduction of new fields and particles, even more exotic than dark matter. Science had crossed into the territory of pure speculation, where the only criterion for truth was the mathematical elegance of the theory, rather than experimental confirmation. While theorists wandered through the labyrinth of abstract models, the observers focused on the one concrete thing they had, the signal itself. If this was a message, it had to contain information. A painstaking process of analyzing the signal's temporal structure began. For the first few weeks, observations indicated a stable pulsation period of roughly 17 hours. But then astronomers noticed subtle shifts. The period started contracting, slowly, almost imperceptibly at first. It was reminiscent of a spinning top winding down. Crucially, this change was non-linear. It adhered to some complex mathematical rule. When the scientists finally plotted the period changes on a graph, they experienced yet another profound shock. The resulting curve aligned with the Fibonacci sequence with mind-boggling precision. This famous sequence, where each number is the sum of the two preceding ones, is ubiquitous in nature, found in the arrangement of sunflower seeds, the spirals of seashells, and the branching of trees. Yet absolutely no one expected to find it encoded in a signal arriving from the galactic depths. This discovery changed everything. A random natural phenomenon, no matter how unusual, would be highly unlikely to conform to such a specific and sophisticated mathematical law. The Fibonacci sequence is a hallmark of complexity, a marker that on Earth is typically associated with biological systems or deliberate intelligence. This was no longer mere noise or a flicker. It was a structured transmission. But what was the meaning behind it? Was it simply a declaration, "I am here and I understand mathematics"? Or was a far deeper message encoded within that very sequence? Scientists immediately began searching for other underlying patterns. They applied every known method of cryptanalysis, scanning the signal for prime numbers and mathematical constants like pi or e. The signal proved to be like an endless onion. Peeling back one layer invariably revealed another, even more intricate one beneath. Embedded within the larger 17-hour cycles were shorter, faster pulsations that coalesced into fractal-like patterns. The more precise the measurements became, the more complex and deliberately meaningful the structure of the signal appeared. It was like a primitive human finding a smartphone on a beach. He sees a glowing rectangle but has absolutely no concept of an operating system, applications, or the internet. Humanity was now that primitive, staring at a technology that exceeded our current understanding by potentially millions of years. The detection of a mathematical structure within that signal marked the point of no return. Suddenly, we couldn't afford to ignore the most profound and disturbing hypothesis: the presence of extraterrestrial intelligence. For decades, Project SETI, the search for extraterrestrial intelligence, spent listening to the cosmos across the radio spectrum, hoping to catch signs of artificial origin. But this search was inherently flawed. It assumed that other civilizations would communicate using radio waves just like us. It was a technological hunt for a needle in a haystack, severely limited by our own current understanding. But what if a highly evolved civilization, one that precedes us by millions of years, communicates using something completely different? What if they possess the power to modulate the luminosity of the stars themselves, essentially creating a kind of galactic internet? By the standards of our current technology, this borders on absolute magic. To force a star to alter its luminosity, one must somehow manipulate the thermonuclear fusion within its core. This demands an energy output comparable to the star itself. To achieve this synchronously across millions of stars requires not just phenomenal power, but technology capable of manipulating the very fabric of space-time. Such a civilization neatly fits into the classification system proposed in the 1960s by Soviet astrophysicist Nikolai Kardashev. He categorized hypothetical civilizations into three types based solely on their energy utilization. Type 1 uses all the energy of its home planet. Type 2 harnesses the total energy of its star, for example, via a Dyson sphere. And Type 3 is a civilization that has successfully mastered the energy output of its entire host galaxy. If the phenomenon of synchronously blinking stars is indeed the result of intentional engineering, it could only have been achieved by a Type 3 civilization, or perhaps even a Type 4, if such a thing exists. This realization was simultaneously exhilarating and utterly terrifying. On one hand, it would confirm that we are not alone in the cosmos, answering the most fundamental question humanity has ever pondered. But on the other, it meant we were merely ants by the side of a road, watching something unimaginably powerful pass by. And this entity chose to send us a sign, but what does it mean? Is it a friendly greeting, a profound warning, or is it simply an insignificant byproduct of their galactic infrastructure? One we, from our primitive vantage point, are fixating on far too intensely? If we accept the hypothesis that the signal is artificial, the immediate question is, why? What is the purpose of such a colossal demonstration? The first thought that comes to mind is contact, a simple, undeniable message: we are here. Perhaps the sending civilization has reached a level of advancement where they can afford to construct a universal beacon visible to all potential younger civilizations like ours. They are simply announcing their presence, extending an invitation to dialogue for any who can observe and decode it. But this version seems far too simplistic. If they possess the capability to manipulate entire stars, they almost certainly know of our existence already. They could have contacted us using a much simpler, more direct method. Why put on such a complex and energy-intensive show? Another far more troubling hypothesis is that this is a warning. A warning about what? Perhaps a coming cosmic catastrophe we are completely unaware of. For instance, vacuum instability, the approach of something from another dimension, or any other apocalyptic event our current science cannot even begin to imagine. In this scenario, the flickering stars are a universal siren, an alarm signal screaming across the cosmos. The complex mathematical structure of the signal might contain information about the nature of the threat, and possibly even methods of salvation, but for now we remain unable to read it. Then there is a third, more philosophical and detached possibility. Maybe the signal isn't meant for us at all. We might simply be accidental witnesses. It could be a form of art for a super-civilization, a galactic symphony of light, or perhaps it's merely a side effect of their galaxy-sized calculating machine, their so-called computronium. It could even be a religious ritual, the meaning of which we will never comprehend. It is entirely possible that to them we are no more significant than bacteria clinging to a speck of dust is to us. They operate on time and space scales we cannot possibly grasp, and their actions might appear miraculous or utterly nonsensical to us simply due to the colossal developmental gap. This thought is perhaps the most unpleasant blow to the human ego. To be a mere spectator in the cheap seats rather than the central focus of the event is something our civilization, which has grown accustomed to viewing itself as the pinnacle of creation, is completely unprepared to handle. The mystery of the blinking stars has breathed new life into the famous Fermi paradox. Formulated by physicist Enrico Fermi, the paradox itself is simple. If the universe is so vast and so old, hosting millions or even billions of potentially habitable planets, why haven't we found any definitive evidence of intelligent extraterrestrial life? Where is everybody? For decades, scientists have wrestled with this question, proposing various solutions. The rare Earth hypothesis suggests that the conditions necessary for complex life are so unique that we truly might be alone in the galaxy. Then there is the Great Filter theory, which posits that some insurmountable hurdle, nuclear war, ecological collapse, a devastating pandemic, destroys most civilizations before they can achieve interstellar travel. Finally, the zoo hypothesis claims highly advanced species observe us but refuse to interfere, treating humanity like animals in a carefully maintained nature preserve. But now, against the backdrop of these blinking stars, all these hypotheses are being re-evaluated. Perhaps the answer to where is everybody has been staring us in the face the entire time. They aren't hiding. They are simply communicating in a way we couldn't conceive of until now. They aren't using primitive radio signals. They are speaking the language of the universe itself, the language of the stars. We have been like people living in a world without radios, wondering why we never hear music. Maybe the Fermi paradox doesn't exist at all. The universe could be teeming with life and intelligence, simply waiting for us to grow up enough to recognize their presence. This discovery could be our very own entrance exam into the Galactic Club. But now we face the crucial question: what do we do next? Should we try to answer? And if so, how? We don't have the technology to make even our own sun blink, let alone operate on a galactic scale. Any signal we send would be akin to an ant screaming in response to an elephant's roar. Or perhaps the wiser choice is not to answer at all. There is a famous contact problem described in Liu Cixin's novel, The Three-Body Problem. It's called the dark forest theory. If you find yourself in a dark forest filled with unseen hunters, the first rule is silence. By announcing your presence, you risk attracting attention from something whose intentions may be far from friendly. Humanity now stands at a profound crossroads, and the cost of making the wrong decision could be impossibly high. Naturally, the news of the cosmic anomaly couldn't be contained within the walls of scientific institutions for long. Despite frantic attempts to keep the information secret until scientists could provide any coherent explanation, a leak occurred. It started as rumors on specialized forums, but once journalists got hold of it, the story cascaded like an avalanche across the globe. Society's reaction was predictable, yet utterly chaotic. The world fractured instantly. For some, this was the greatest event in history, proof that we were not alone. New religions sprang up, deifying the star conductors. Millions worldwide spent their nights gazing skyward, meditating, and attempting to establish mental contact with a higher intelligence. For others, it fueled unprecedented panic. Economic markets imploded, governments declared states of emergency, conspiracy theories flourished. Some insisted that governments had known about this for decades and were covering up the truth. Others believed it wasn't aliens at all, but a divine omen foretelling the end of days. A third camp accused scientists of creating the anomaly themselves, perhaps using some kind of super collider and inviting catastrophe onto Earth. The scientific community found itself under colossal pressure. On one hand, the public demanded immediate answers the scientists simply didn't possess. On the other, they were being blamed for everything under the sun. For the first time in human history, science was confronted with a phenomenon it was utterly incapable of explaining, and this severely eroded its authority in the eyes of the public. People were accustomed to science having all the answers. When those answers vanished, millions turned instead to mysticism, superstition, and raw fear. This resultant social and psychological crisis proved to be just as daunting a problem as the astrophysical mystery itself. It became evident that even if the signal turned out to be harmless, its mere existence had permanently altered human civilization. We could never again look at the stars the same way. The sense of cosmic loneliness that had defined our entire history was replaced by the unsettling realization that we were being watched. Faced with widespread panic and overwhelming uncertainty, global governments and scientific organizations were forced into an unprecedented collaboration. They established an international consortium named AEGIS. AEGIS was tasked with coordinating all research related to the phenomenon and developing a unified strategy for a global response. Its members were intentionally diverse, not just astrophysicists and mathematicians, but also linguists, anthropologists, psychologists, philosophers, and even theologians. The objective was immense, not simply to study the signal, but to attempt to understand the intelligence behind it, if such intelligence existed, and to evaluate every possible consequence for humankind. As a top priority, the world's largest telescopes, both ground-based and orbital, were fully redirected toward the anomaly. A relentless total monitoring of the sky began, 24 hours a day, 7 days a week. New research programs were immediately launched to search for any secondary manifestations of this strange activity. Were they looking for gravitational waves linked to the pulsation, neutrino bursts, any other particles or emissions that might accompany the primary signal? Simultaneously, linguists and cryptographers analyzed the structure of the incoming data, attempting to build models of a hypothetical language of the stars. Their core assumption was that any intelligence capable of such a feat must grasp the universal laws of mathematics and physics. Therefore, these concepts must form the foundation of their communication. This was an attempt to find the Rosetta Stone of cosmic scale. Psychologists and sociologists modeled various scenarios for humanity's reaction to different outcomes. What if the signal proved hostile? Conversely, what if it contained a gift, new technologies, a cure for all diseases, the secret to eternal life? Was humanity truly ready for such a radical change? Would it lead to greater peace, or only accelerate existing wars and inequality? Project Aegis quickly became the most expansive and complex scientific initiative in history. It demonstrated that, when faced with the great unknown, humanity was capable of setting aside its petty squabbles and unifying. Yet deep down, every project member understood they were preparing for an encounter that could prove to be either the greatest blessing or the final judgment for our species. But let's return to the signal itself. After several months of continuous observation, the accumulated data set revealed another truly astonishing detail. The pulsation wasn't perfectly uniform across the sky. Some regions showed slightly stronger intensity, others were weaker. When scientists finally mapped these fluctuations onto the celestial sphere, the resulting image gave them chills. The map of signal intensity resolved itself into an incredibly complex, three-dimensional structure. It was a hologram. The image itself was fuzzy and indistinct, like a faded photograph, but certain key details could be made out. It was a double helix, strikingly similar to a DNA molecule. But it wasn't just a basic DNA strand. Inside the helix, they could discern structures resembling planetary systems, and the helix itself seemed to be woven into a larger galaxy-like pattern. It looked like a diagram, a sophisticated blueprint of something. What that something was, nobody could definitively say. Was it a map, an assembly guide for some colossal mechanism, or perhaps a symbolic representation of life throughout the cosmos? The discovery of the hologram immediately triggered a new wave of heated debate. Skeptics argued it was merely pareidolia, the innate tendency of the human brain to find familiar patterns in random data. They pointed to examples like faces in clouds or on the Martian surface. They demanded stricter statistical proof that this was not simply a random distribution of intensity fluctuations, but the proponents of the signal hypothesis countered that the sheer complexity and inherent order of the image far exceeded the probability of pure randomness. Furthermore, the image wasn't static, it was changing very slowly, as if illustrating some evolving process. Certain fragments of the helix would brighten, others would dim, almost as if someone was demonstrating a slow, majestic process unfolding over perhaps millions of years. This discovery presented the cryptographers and linguists working on Project Aegis with a new, exponentially more difficult challenge. They now had to decode not just a one-dimensional sequence, but a three-dimensional, time-varying visual representation. It was the difference between solving a simple crossword puzzle and trying to decipher the plot of a silent, heavily edited film in a language they didn't even recognize. Humanity had received its first message from the depths of the cosmos. It was inexpressibly beautiful and absolutely incomprehensible. Despite how fantastical the idea seemed, the hypothesis of an artificial signal was rapidly gaining credibility, but it immediately raised one very uncomfortable question. Why now? Our civilization has existed for an insignificant blink of an eye by cosmic standards. We've only gained the systematic capability to scan the entire sky in the last few years. If this cosmic beacon has been transmitting for millions of years, why are we only just noticing it now? Is it truly an incredible coincidence that we built the necessary instruments precisely when the show began? Or was it switched on specifically for us? This line of thought was so steeped in anthropocentrism that most scientists initially refused to even consider it. The idea that a Kardashev Type 3 civilization would specifically turn its attention toward us felt like the ultimate height of human arrogance. But as other explanations fell away, this version remained one of the few plausible alternatives. What if they had been waiting all along, waiting for us to reach a specific technological threshold, perhaps the launch of the first powerful radio telescopes or breaking into orbit or the creation of the Internet served as the very signal that indicated that intelligent life, ready for dialogue, had emerged on this small planet in the Orion Arm. Maybe they chose not to interfere sooner so as not to disrupt our natural development, adhering to some form of prime directive, much like the one from Star Trek. But now that we ourselves have begun making noise on the radio waves and leaving cosmic footprints, they decided the time was right. They activated their beacon, fine-tuned specifically, so that we would guaranteeably detect it with our current technological capabilities. This idea certainly flatters our ego, but it also places an enormous burden of responsibility upon us. If this is true, every subsequent move we make will be analyzed. We are no longer simply existing on our planet, we are now on a stage. The way we conduct ourselves, whether we unite in the face of the unknown or descend into war and internal conflict, may determine how our invisible elder siblings of the cosmos regard us. Perhaps this isn't merely a contact, perhaps it's an examination. Let's take a slight detour from the big global questions and examine this phenomenon from a different, more technical perspective. How exactly might this work? What mechanism could possibly cause a star to visibly flicker? The theoretical physicists working on Project Aegis have put forward several potential mechanisms, each more fantastic than the last. The first idea revolves around neutrinos. Neutrinos are elementary particles known for their extremely weak interaction with matter. Billions of them fly through your body every second, originating from the sun, and you never even notice. But imagine if we could generate an incredibly powerful, highly focused beam of a specific type, say sterile neutrinos, that could interact with matter under special conditions. If you fire such a beam into a star's core, you could theoretically alter the rate of fusion reactions, either suppressing them or boosting them. This would allow you to precisely control the star's luminosity. The technology required to generate and focus such beams over interstellar distances is far beyond our current imagination, but at least it doesn't directly violate the known laws of physics. The second hypothesis is even more exotic, the use of microscopic black holes. According to some theories, primordial black holes, the size of an atomic nucleus, may have formed during the Big Bang. If we could learn to control these objects, they could be deployed toward a star. As one flew through, it would absorb a fraction of the star's matter, temporarily reducing its mass and luminosity. By perfectly synchronizing the movement of trillions of these micro-black holes, the required observable effect could be achieved. The third and perhaps most outrageous idea involves the direct manipulation of space-time itself. Imagine a technology capable of creating localized bubbles of distorted space. If you surround a star with such a bubble, you could change its apparent brightness for an external observer without actually affecting the star itself. It would essentially be the ability to create and destroy gravitational lenses at will. This is truly God-tier technology, the ability to physically restructure the universe on a whim. While these hypotheses are little more than educated guesses, they illustrate the direction of scientific thought. Scientists are trying to pinpoint the technological breakthrough that separates us from the signal's creators, and that gap, it seems, is measured not in centuries, but in entire cosmic eras. While one faction of the scientific community struggled to decipher the incoming signal, another posed the exact opposite question. Could we somehow jam it, or at least test if the source was even reacting to our presence? This led to the birth of one of history's boldest and most audacious experiments, Project Echo. The core idea was simple. If we couldn't make the stars blink, maybe we could alter something within our own solar system, just enough for it to be noticed on an interstellar scale. After lengthy debate, the only available tool we had was selected, our own sun. The plan was to use every spacecraft at humanity's disposal to create a temporary, highly diffuse ring of dust around the star. This involved altering the trajectories of several large asteroids from the main belt, guiding them into an orbit near the sun. There, solar wind and intense radiation would cause them to rapidly break down, forming the necessary dust cloud. Calculations showed that this cloud would momentarily, for just a few fleeting minutes, slightly alter the sun's overall luminosity. The change would be minuscule, negligible, yet potentially sufficient to signal that someone was here trying to respond. The project was incredibly risky. Any miscalculation could send an asteroid hurtling toward Earth or another inhabited planet. Environmental groups protested the pollution of the solar system. Nevertheless, following lengthy international negotiations, the project finally received the green light. On the designated day, D-Day, all of humanity watched, holding its collective breath as the plan unfolded. And it worked. For a few minutes, our sun genuinely dimmed by a fraction of a percent. We had sent our reply, a tiny, pathetic cough answering a deafening cosmic symphony. Then came the wait. Every telescope was trained on the sky, registering the slightest potential change in the galactic pulsation. An hour passed, a day, a week. Nothing changed. The cosmic metronome continued its unwavering beat, completely unperturbed. Our response had not been heard, or perhaps it had simply been ignored. It was a sobering and humiliating fiasco, illustrating yet again the vast chasm between our capabilities and those responsible for this cosmic phenomenon. We were not even ants trying to shout at an elephant. We were paramecia in a drop of water attempting to flag down the human peering through the microscope. The failure of the ECHO project forced many scientists to revisit their most fundamental assumptions. What if we have been misinterpreting the very nature of this phenomenon all along? What if it is not a signal, not a message, and not the result of intelligent activity? What if we are observing an entirely new, natural phenomenon that our science simply hasn't yet discovered? This perspective, known as the new naturalism hypothesis, began to gain significant traction. Proponents argued that attributing intelligent origins to the phenomenon was merely a display of human hubris and limited imagination. This wouldn't be the first time it happened in the history of science. There was a time when people believed lightning was the wrath of the gods and comets were omens of disaster until their physical nature was understood. When pulsars were first discovered, their highly regular signals were initially mistaken for the transmissions of extraterrestrial civilizations, jokingly earning them the nickname LGM, Little Green Men. Later we learned they were merely rapidly rotating neutron stars. Perhaps now we stand on the verge of opening a new chapter in physics. Maybe there is some unknown mechanism that causes stars of a certain type to enter into global resonance. This could be tied to the properties of dark energy, which accelerates the expansion of the universe, or perhaps to hidden dimensions predicted by string theory. But what about the mathematical complexity of the signal, the Fibonacci numbers, and the holographic image? Naturalism advocates countered that nature itself is perfectly capable of creating incredibly complex and highly ordered structures. We find Fibonacci sequences in plants and fractals in snowflakes and coastlines. Why couldn't something similar arise on cosmological scales? Perhaps the laws governing the universe are far more intricate and intelligent than we currently imagine. And what we mistake for artificial intelligence is, in reality, the manifestation of the inherent intelligence of the universe itself. This hypothesis was, in its own way, comforting. It relieved us of the fear of a powerful and unknown other. But it also left humanity exactly where it started, in a state of profound cosmic loneliness, facing an unfathomable and indifferent universe. Let's assume for a moment the natural origin hypothesis is correct. What exactly is this new physical phenomenon we're observing? One of the most robust models addressing this is known as the vacuum phase transition theory. According to current cosmology, our universe exists in a state called a false vacuum. This essentially means its current energy level is not the lowest and most stable possible. There exists a true lower energy state, the true vacuum. The shift from false to true vacuum is a phase transition, much like water freezing into ice. This transition would begin at a single point in the cosmos, forming a bubble of true vacuum that would then expand outward at the speed of light, annihilating everything in its path. Within this bubble, the laws of physics would be fundamentally different, making our current existence impossible. It's truly one of the ultimate doomsday scenarios. But what if this transition isn't catastrophic? What if the universe isn't plunging into the true vacuum, but merely oscillating right on the edge of that transition? Theorists have suggested that dark energy, the force driving the universe's expansion, could be causing these subtle fluctuations. It's like a kettle of water that's shivering just below the boiling point. It's twitching, but unable to fully transition into steam. These hypothetical vacuum fluctuations could, at a micro level, be subtly altering the fundamental physical constants we've discussed. Crucially, they wouldn't do this randomly, but according to a complex law inherent to the structure of space-time itself. This complicated rule could be generating the fractal and Fibonacci-like patterns that we are currently observing. Certain types of stars, in turn, could act as highly sensitive detectors for these oscillations, entering into resonance with them and subtly changing their luminosity. This theory successfully explained the signal's three key features: the synchronicity, the entire universe oscillating at once, the selectivity, only specific stars resonating, and the complexity of the signal itself. It transformed what seemed like a frightening alien transmission into the majestic music, the very breath, of the universe itself. However, it carried one deeply unsettling implication. If the universe is merely trembling on the verge of a phase transition, it means it is fundamentally unstable, and nobody can guarantee that at any given moment these harmless oscillations won't spiral into an irreversible process, and our world will simply cease to exist. Whether this phenomenon is artificial or natural, it has fundamentally forced humanity to redefine its place in the cosmos. For all of history, we have lived with the perception that space is distant, cold, and mostly empty, a mere backdrop to our terrestrial lives. Yes, we studied the stars and launched rockets, but it was always like studying the ocean while standing safely on the shore. We never truly felt we were a part of it. The discovery of these blinking stars changed all of that forever. Space is no longer just a backdrop. It has proven to be vibrant, dynamic, and packed with mysteries that directly concern us. It is like someone who has lived their entire life in a soundproof room, suddenly hearing music filter through the wall. The world has become bigger, more complex, and far less predictable. This triggered a profound existential shift. Our previous pillars, religion, national narratives, consumer culture, have been shaken in the face of such a colossal mystery. Why argue over borders and resources when our entire civilization is merely a speck of dust witnessing a cosmic spectacle? This has spurred the growth of a new worldview which we might call 21st century cosmism. People have become far more interested in science, philosophy, and the future of humanity as a species. Interest in space travel has been rekindled not as a superpower race but as an absolute necessity. The idea of settling other planets is no longer just a beautiful dream from science fiction. It is now widely viewed as the only realistic insurance policy in case our homeworld proves less stable than we hoped, or if the signal's originators are less than friendly. This phenomenon has become the catalyst that may finally push humanity out of its planetary cradle and force us to grow up. It has held a mirror up to us, and in it we see not just residents of Earth, but citizens of the universe, individuals who must now come to terms with their rights and responsibilities in this vast and strange new reality. While philosophers debated humanity's place in the cosmos, engineers and programmers focused on the most ambitious task of all, building an artificial intelligence capable of deciphering the incoming signal. The human mind, for all its brilliance, proved too slow and fundamentally limited to process such a colossal, multidimensional data stream. The consensus was that only a next-generation self-learning neural network might uncover the hidden patterns within what humans perceived only as chaos. Thus, Project Oracle was launched across the world's largest supercomputing centers. The system was fed every piece of data collected from every telescope, alongside the entirety of human knowledge across physics, mathematics, linguistics, biology, and even the arts. The underlying hypothesis was that the AI shouldn't just seek mathematical patterns. It had to search for analogies, metaphors, and cross-disciplinary connections that might lead to a breakthrough. For several months, Oracle remained silent, processing petabytes of information. Then it began delivering results, and these results were more bizarre than anything encountered before. The artificial intelligence discovered not one, but multiple nested informational structures within the signal. On one level, it was undeniably complex mathematics, seemingly describing fundamental laws of physics, some of which were entirely unknown to us. On another level, the signal had a structure strikingly similar to a musical composition, complete with harmonies, rhythms, and recurring themes, but constructed upon principles radically different from earthly music. On the third level, the AI found something it classified as a quasi-biological code, sequences that resembled genetic code in their complexity and information density, yet were far more intricate. Most importantly, all these levels were intrinsically interconnected. The mathematical formulas defined the harmony of the music, and the music, in turn, encoded the biological information. It was like a multidimensional language where the same message could be read simultaneously as a scientific treatise, a symphony, or a set of instructions for creating life. This discovery meant we were dealing with a consciousness for which science, art, and life itself were not separate domains, but a single, indivisible whole. To truly understand them, we may have to fundamentally restructure our own way of thinking. The findings delivered by the Oracle Artificial Intelligence have been published, immediately igniting a new firestorm of debate. What exactly does this complex, layered structure signify? One of the most compelling interpretations has been dubbed the universal genome hypothesis. According to this theory, the signal contains complete information regarding life throughout the cosmos, a true source code of creation. The mathematical layer appears to outline the fundamental physical laws essential for life's existence. The musical layer perhaps describes the processes of evolution, their rhythm and harmony, and the biological code, that is, the program of life itself, potentially including examples of diverse life forms flourishing on other planets. If this hypothesis holds true, it represents the single greatest gift humanity could ever conceive. It is the answer to every fundamental question. It is the key to understanding how life originated, how it evolves, and perhaps even how to create it artificially. Access to this information could grant us the technology for terraforming planets, eradicating all diseases, and achieving true immortality. Yet, like any great power, it carries an immense risk. What if, like inexperienced programmers, we attempt to utilize this source code without fully comprehending its underlying structure? We might inadvertently unleash something catastrophic, an uncontrollable virus, or an aggressive new life form that could instantly devastate our own biosphere. Alternatively, should this information fall into the wrong hands, it could become the ultimate weapon. Imagine a nation developing biological warfare based on alien principles, against which we would have absolutely no defense. This reality forced the international community to make an unprecedented decision to impose a global moratorium on all attempts at practical application of the signal's data. All information was immediately classified, and access was restricted to a small, carefully vetted circle of scientists. Humanity finds itself in the position of Aladdin, having found the magic lamp, but terrified to rub it. We now hold a power that can either elevate us to the stars or bring about our total destruction. The burden of that choice rests squarely upon the shoulders of this generation. Let's put aside the complex theories for a moment and return to simple human perception. What do we truly feel when we gaze up at those twinkling lights? For millennia, the night sky was humanity's ultimate symbol of eternity, peace, and permanence. The North Star was fixed, the constellations followed predictable, slow trajectories. This was our anchor against the chaos of existence, a reminder that something greater and more lasting endured beyond our short lives. Now that symbol of stability is gone. The sky has become alive, mutable, and unpredictable. It is no longer just a beautiful image, it's become an entity, speaking to us in a language we cannot understand. This evokes a complex, mixed feeling. On one hand, there is the reverent awe, what philosophers term the sublime. It's that immediate sense of utter insignificance when confronted by something infinitely vast and powerful. It's the very same feeling you experience standing at the edge of the Grand Canyon or watching a tempestuous ocean. It washes away our pettiness and daily worries. On the other hand, we feel a deep, primal anxiety. The disruption of the established cosmic order is inherently terrifying. It is akin to the sun suddenly rising in the west. This fundamentally undermines our trust in the universe. We can no longer be certain that tomorrow will resemble today. This duality, or balanced against anxiety, has become the new emotional baseline for human civilization. Psychologists are documenting a rise in what they term cosmic anxiety disorder. Yet simultaneously, many report a profound new sense of meaning and a feeling of genuine belonging to something magnificent. Perhaps this was the exact intention of the signal's creators, if they exist at all, not merely to transmit data, but to fundamentally alter us on an emotional plane, to shake us out of apathy and force us once again to confront the big questions. Who are we? Where did we come from? And where exactly are we headed? The stream of data analyzed by the Oracle revealed yet another anomaly. The signal wasn't perfectly uniform across all directions. there was a single point on the celestial sphere from which it seemed to arrive slightly earlier, by just a few milliseconds. This point was located toward the center of our galaxy, within the constellation Sagittarius. As is well known, this is the location of the supermassive black hole, Sagittarius A star. This discovery gave rise to a new concept dubbed the central repeater hypothesis. According to this hypothesis, the signal's source is not omnipresent, but localized, perhaps right at the galactic core. What we observe across the entire sky is merely a reflection or re-emission of that primary source. How might this work? Imagine a staggeringly powerful transmitter located at the heart of the Milky Way. It emits some form of radiation, perhaps those hypothetical sterile neutrinos or gravitational waves, that spreads outward in all directions. This radiation reaches stars, interacts with them, and causes them to change their luminosity. Crucially, it affects stars of the same type in the exact same manner. Thus, all the stars in our galaxy become a gigantic network of passive repeaters, synchronously flashing in time with the central transmitter. The fact that we see this same effect in other galaxies could be explained by assuming that every major galaxy has its own supermassive black hole and possibly its own transmitter, all perfectly synchronized with each other. This theory elegantly solved the problem of superluminal signal propagation. The signal itself doesn't need to travel faster than light. It only requires that all transmitters activate simultaneously, a feat achievable if they were created and programmed eons ago. This hypothesis also gave new meaning to the holographic DNA image. Perhaps it wasn't just a picture, but the sender's address. Look for us at the galactic center, near life similar to your own. It sounded like an invitation, but an invitation to the most dangerous and chaotic place in the entire galaxy, in direct proximity to a star-devouring monster. The hypothesis of a transmitter at the galactic core was thrilling, but proving it was another matter entirely. Directly observing the center of the Milky Way is incredibly difficult. It is shrouded by thick clouds of interstellar dust and gas that completely block visible light. Our only way to study this region is through radio waves, infrared, and X-rays. Nevertheless, every available radio telescope was immediately focused on the area surrounding the supermassive black hole, Sagittarius A star. Scientists scoured the data for anything unusual: anomalous radio sources, periodic energy bursts, strange gravitational fluctuations. Initially, they found nothing. The galactic center was just as noisy and chaotic as it always had been. But then, while analyzing the accumulated data using the neural network dubbed Oracle, one tiny but crucial clue emerged. Several stars are known to orbit the supermassive black hole on highly elliptical paths. Observing their movement has long been the gold standard for precisely measuring the black hole's mass. Oracle detected minute, periodic deviations in the motion of one of these stars, known as S2, specifically tiny wobbles away from the trajectory predicted by general relativity. These deviations were so small they pushed the very limits of measurement accuracy. Crucially, however, their period matched the pulsation period of the cosmic signal. This was indirect, yet compelling evidence. Something near the black hole was exerting an extra influence on S2. It might be the gravitational pull of an unseen object orbiting Sagittarius A star, but what kind of object? Calculations indicated its mass must be enormous, several times that of Jupiter. Yet it emitted no radiation in any detectable spectrum. It was an invisible, superdense, and massive anomaly. Perhaps this was the transmitter itself, or at least a major component of it. This discovery sparked a new wave of enthusiasm. The mystery was no longer abstract or universal. It now had a concrete address. Humanity finally had a goal: to reach the center of the galaxy and see it with our own eyes, a task that might require millennia and technologies we can only dream of today. But now we knew where to go. Let's take a moment and imagine that future humanity manages to accomplish this incredible interstellar voyage. What might they find there at the heart of the Milky Way, next to that light-devouring abyss? The scenarios are numerous, and each one is ripe for a science fiction epic. Perhaps they will discover a gigantic artificial structure encircling the black hole itself, something akin to a Dyson sphere, but constructed around a gravitational well rather than a star. Such a structure could harness the colossal energy released as matter falls into the black hole, and the very transmitter we detected might be only one of its many functions. Who built this megastructure? Perhaps it is the legacy of a long-vanished civilization, one that left behind this automated beacon, much like we leave behind enduring monuments. They may have vanished millions of years ago, yet their creation remains active, broadcasting into eternity the silent testament that they once existed. A second, perhaps more unsettling scenario suggests that what we find is not a structure, but a being. What if consciousness in the universe can take forms completely alien to us, transcending biology entirely? Imagine a plasma or gravitational entity, a mind capable of sustaining life within the extreme conditions of a black hole's accretion disk. For such a being, perhaps composed of pure energy or warped space-time, manipulating the luminosity of stars might be a natural form of communication, much as speech is for us. An encounter with this kind of intellect would fundamentally challenge our very definition of life. There is a third option, the most metaphysical of all. Perhaps the galactic center holds neither an object nor a creature, but a kind of reality node, a point where our universe touches other dimensions or parallel realities. And the signal we are receiving may not be a deliberate message, but rather an echo, seeping into our reality from the inverse side of creation. If this is the case, the journey to the galactic core would be a voyage not just through space, but beyond the very confines of our reality. We cannot know which of these versions will prove true, but the very presence of such a goal, such an enormous mystery, holds the power to steer the development of our civilization for millennia to come. As scientists focused their efforts on the distant future, politicians and military leaders grappled with the immediate and pressing reality. The detection of a potential signal source from the galactic core fundamentally reshaped the global geopolitical order. Space was no longer merely a domain for academic research and commercial satellites. It instantly became the premier strategic frontier. A new space race was launched, but this time it was not between two superpowers, but among every nation possessing spacefaring capabilities. The primary goal of this race wasn't simply reaching the Moon or Mars. It was the rapid development of technologies that could guarantee Earth's safety against a potential external threat and secure a decisive advantage in any future contact scenario. New planetary defense systems were being engineered, designed not only to deflect asteroids but also capable of countering hypothetical hostile vessels. Advanced new telescopes were commissioned, able to observe the galactic center with unprecedented detail. At the same time, research surged into fundamentally new propulsion methods, photonic, ion, and even drives based on the theoretical concept of the warp engine capable of bending space-time itself. Simultaneously, the best minds on Earth tackled the complex problem of the language of contact. If a more meaningful message was ever received, how could we be sure we had interpreted it correctly? The very concepts of peace or war might hold profoundly different meanings for a civilization whose experience and biology are radically different from our own. This led to the creation of an entirely new field, exolinguistics. Its purpose was to design a universal language, one founded not on human words or cultural context, but on the immutable concepts of mathematics and pure logic. This wholesale militarization and securitization of space was an inevitable, primal reaction to confronting the great unknown. Humanity, like any biological species facing the unclear and potentially hostile, instinctively prioritized survival and defense. Yet many feared that by preparing solely for war against a hypothetical enemy, we might forfeit the chance for peaceful dialogue and the greatest discovery in our history. The ultimate paradox was clear. To be truly ready for contact, we had to advance technologies that held the equal potential for our self-destruction. Hidden in the shadow of massive government projects and military programs, another movement quietly emerged, one that was perhaps less noisy, but certainly no less crucial. This was the movement for cosmic consciousness. Its advocates, a diverse group including not just scientists and philosophers but artists, musicians and poets, argued that humanity's primary task was not to build the most powerful telescope or the fastest rocket, but to prepare our own consciousness for contact. They maintained that we cannot comprehend the universal mind until we comprehend ourselves. We cannot initiate a dialogue with the other until we learn to dialogue with each other. This movement called for a radical global reassessment of our values: cooperation instead of competition, creation instead of consumption, planetary consciousness instead of nationalism. Artists produced paintings and installations attempting to visualize the intangible signal. Musicians composed symphonies using the mathematical patterns found in the pulsations of stars as their musical foundation. Science fiction writers explored every conceivable future scenario, from utopias to dystopias, thus preparing humanity for any potential outcome. It was a cultural renaissance of sorts, spurred by a gaze into the cosmic abyss. People began to realize that our greatest treasure was not technology but our capacity to feel, to create, and to question. And perhaps these very qualities, curiosity, empathy, and the pursuit of beauty, are the universal language that any intelligence in the cosmos would understand. Perhaps the best answer we can send into space is not a radio signal or a starship, but a Mozart symphony, a Da Vinci painting, or simply a sincere desire to understand. This movement offered no specific policy solutions, but it cultivated the cultural and psychological soil from which those solutions could ultimately grow. It reminded us that before we venture out to the stars, we must first put our own house and our own soul in order. Several years had passed since the initial discovery. The shock and panic that followed had long since given way to routine. Humanity adapted to the flickering stars, as we adapt to everything. They became part of our daily lives, a background hum mentioned in the news, but no longer inspiring the awe or fear they once did. Project Aegis continued its work, though without any major breakthroughs. The signal remained stubbornly undeciphered. The new space race pressed on, but it had devolved into a slow, costly competition of budgets and technological resources. Then on an otherwise ordinary day, the truly unexpected happened. The signal changed. The 17-hour cycle, which had remained absolutely constant for years, began to falter. The pulsations grew erratic, chaotic, and then they simply stopped. Completely. The sky returned to the way it had always been, calm, eternal, and silent. The stars stopped blinking. For several hours, panic reigned within Project Aegis. The consensus was equipment failure. But every telescope across the globe confirmed the same reality. The signal had vanished as abruptly as it had arrived. This disappearance raised even more profound questions than its initial arrival. What was it? Had the transmitter at the galactic center simply broken down, or had it been shut off? If shut off, why? Perhaps our clumsy reply via Project Echo had finally been noticed and dismissed as either hostile or too primitive, and they had simply stopped talking to us. Or was it the final stage of a test that we had failed? Or maybe, far more simply, it truly was just a natural phenomenon that had run its course. The silence that settled over the universe was more deafening than the loudest pulse of the signal. While the signal existed, humanity had a purpose, a unifying mystery. Now only emptiness and profound ambiguity remained. We felt like someone who had spent years in a fascinating conversation with an invisible partner, only for that partner to suddenly hang up the phone without a word. It felt like a deep loss. Humanity felt profoundly alone again. But it was a different kind of loneliness. Not the naive solitude of a child unaware that others exist, but the bitter isolation of an adult who has tasted the possibility of friendship, only to be rejected. But the story didn't end there. Weeks after the initial signal vanished, astronomers observing the galactic core detected something entirely new. From the area where the source originated, a single, incredibly powerful, and highly focused pulse erupted. It was not light, radio waves, or neutrinos. Our instruments failed to identify its composition. They merely registered a momentary distortion in the fabric of space-time. And this pulse was aimed precisely, unmistakably, at our own solar system. Moving at the speed of light, it gave us a timeline, 26,000 years before impact, the exact distance separating us from the galactic center. What was it? A final goodbye, a warning, or perhaps something far more significant? The artificial intelligence oracle, after analyzing the pulse's structure, delivered what it deemed the single most probable explanation. It was a data packet, incredibly densely packed. Apparently, it contained the very instruction set, the universal genome, that was encrypted in the original global signal, but now compressed and highly concentrated. It was a gift, or a Pandora's box. A package had been sent, and humanity now has 26 millennia to prepare for its arrival. This time frame, vast by the measure of a single human life, is just a cosmic blink of an eye. It presents us with an entirely new imperative. We must not simply survive as a species for the next 26,000 years. We must preserve and expand our knowledge, passing it down through hundreds of successive generations. We must build a civilization worthy of receiving this gift, one capable of utilizing it wisely. This is the greatest challenge in our history. We no longer face a mere mystery. We have a defined goal and a precise deadline. 26,000 years. The clock is officially counting down. The destiny of humanity, whether we evolve into a galactic civilization or vanish before we even unlock the package, now rests entirely on our shoulders. It depends on whether we can finally overcome our differences, our petty greed, and our intrinsic foolishness. It depends on whether we can finally become one unified humanity, gazing toward the future. And so we stand here at the threshold of this immense journey. What does this story truly signify for us, the people living right now? It signifies that we are living in the most astonishing of times. We are the first generation to truly know that we are not alone. We are the generation entrusted with taking the first step on a path spanning 26,000 years. This responsibility might seem daunting, but it is also what gives our lives incredible meaning. Every action we take, every scientific discovery, every piece of art, every single act of kindness and cooperation, these are tiny contributions to the magnificent future awaiting our descendants. We are laying the foundation for a cathedral that will only be finished millennia from now. We are planting trees whose shade we will never rest under, but we do this because we believe in the future. The mystery of that signal, even though it has vanished, has left us with the greatest legacy, hope and purpose. It reminded us that the universe is infinitely complex and beautiful, and that the most captivating part of it is not finding the answers, but the pursuit of knowledge itself. It showed us that even the smallest civilization, lost on the edge of a galaxy, can be part of something truly monumental. And now, as we look up at the calm, silent night sky once more, we see it differently. We know this silence is only temporary, that deep within the cosmos, a message awaits us. And somewhere far away, perhaps in the galactic center, someone is waiting for our reply. We still have a very long road ahead of us, but humanity has never feared long roads after all. Those are the only ones that lead to the stars. So let us continue to look up, continue to ask questions, and continue to dream. Because our cosmic journey is truly just beginning. And so, our long exploration into the heart of this great mystery draws to a close. It all began with a simple, yet impossible fact. Stars across the entire universe started blinking in perfect unison. We moved through every phase of scientific inquiry, from initial denial and frantic attempts at simple explanations, right up to embracing the most fantastic hypotheses imaginable. We watched this mystery reshape our society, redefine our science, and challenge our philosophy. We confronted the concept of an intelligence so ancient and powerful that it uses stars themselves as letters in its cosmic message. We peered into the abyss of misunderstanding, attempting to decipher a language based on mathematics, music, and the very essence of life. And ultimately, we are left with an even greater mystery, a message currently traveling toward us across millennia. This story has no end. You and I are living in one of its very first chapters. What happens next depends not only on our descendants, but on us, on the core values we choose to build our civilization upon today. The central lesson of this tale, perhaps, is that the universe is a far stranger and more wonderful place than we could have ever imagined. And the most crucial thing is not to fear that strangeness, but to meet it with curiosity and an open heart. Thank you for spending this time with me, contemplating the eternal. I hope this story has helped you relax and settle in for a peaceful night's sleep. If you enjoyed this discussion, please subscribe to the channel, hit the like button, and tap the bell so you don't miss our next journeys. And now, before you drift completely off to sleep, I want to leave you with a question. Imagine the message reaches Earth tomorrow, and within it, there is only one simple phrase that we are able to understand. What single phrase would you hope to read? Write your answer in the comments below. I would truly love to hear what you dream of. Good night, and may you have clear dreams.